All right, so in this lesson, we're going to start talking about graphs of polynomial functions. And we have a lot of vocabulary to cover today, so it's really important that you write this vocabulary down and make sure you have things labeled correctly. So let's first talk about what a polynomial is. So polynomials really mean, if we look at the definition here, if something has one term, that would be a monomial, two terms is a binomial, three terms is trinomial, and polynomial is just what we call something that has 4 or more terms. And really, polynomial actually incorporates more than just that. It could just be anything. So it could be anything from 1 to 4 terms falls under the definition of polynomial. All right, so we can do a few things with polynomial. The first one is standard form. So standard form, what that's going to do is have us reorganize the polynomial from highest degree down to the least. All right, so we're going to look at the exponents here. Notice that this polynomial that we've been given, if you copied it down already, I just changed the numbers, so make sure that yours reflects that. This has 4 terms. If I put these in order, this would be y equals, so I'm going to go highest exponent down, so I notice there's an exponent of 6, so 7x to the 6th, then an exponent of 3, which would be 3x to the 3rd, an exponent of 2, so plus 4x squared, and this x just has an exponent of 1, so that would be minus 8x. I also want to add 1 on here so we can fix our example here. If you will put a minus, we'll say 9. So now this has 5 terms, and we'll put a minus 9 at the end. Okay, so a few different pieces of vocabulary. One, this minus 9 at the end, this is a constant. And just like standard form for quadratics, this will end up being our y-intercept, so we can go ahead and note that. This term that's in the beginning is the leading term, and it tells me a few different things. So I have the leading term itself is going to be 7x to the 6th. I also have a leading coefficient, which is just going to be the the number in the front, the coefficient. And then this term also tells me the degree. And so the degree is going to equal the exponent up there. So this is a polynomial with degree 6. All right, now this leading term, degree, and coefficient, this is probably one of the most important parts for what we need moving forward. So make sure you understand that. All right, so now we're going to talk about something called end behavior. And end behavior is what a polynomial does on its ends. So note that pretty much every graph that you're going to come up with, right, any of the graphs that are on my wall, all of them have 2 different ends to them. So you're going to end up having 2 end behaviors for those. And we probably won't cover things that don't have 2 end behaviors until much later in the semester. All right, so we're going to take a second and put our pencils down, and I just want you to watch and look at the screen here. So what I first want you to notice is what happens when we have an odd degree. So that's going to be these 2 things on the left. And so if I look at what's happening when we have an odd degree, notice what's happening to the ends in each of these examples. That when we have an odd degree, the ends are going to go in opposite directions. And so what I mean by when the degree is odd, notice that these have degrees of 1 and 3 and 5. So when the degree is odd, the end behaviors are opposite. The other way for you to draw a little thing in your notes is to say that the end behaviors go either up and down or down and up. So the arrows on the ends are going to end up pointing different directions in the end. All right, if we look at our even end behaviors, so now we're on this right side. On our even end behaviors, notice what's happening on the ends. The ends are going the same direction both times. So for instance, we get graphs that either go up and up or they will go down and down. So that is number 1, very important for you to know. Now, how do we know if which scenario we're going to fall into? So now I'm going to zoom back in here and look at what happens when it's positive. So when things are positive, when my leading coefficient is positive, notice on the right side, when we're positive, the right side is going to go up. All right, so you're going to want to write that down. And using that same logic, then, if the leading coefficient were negative, we'll come down here and see when the leading coefficient is negative, on the right side, my end behavior is going down. All right, so you should have those 4 things written down before moving forward. All right, the last thing I want to note to you about end behavior is how we note that. So if we have arrows in different ends, there's different ways to say what's happening there. And honestly, I'm going to give you a little bit of a shortcut, and then we'll kind of break this down when we get in class. So in this top right quadrant, this is positive, negative, negative, positive, negative, negative, positive, negative. So the way that end behavior is written most normally is we'll say things such as x goes to positive infinity, f of x, which is the y value, is going to go to, in this case, positive infinity. This same kind of fill-in-the-blank value or format can be done with any of these. So on this bottom one, it would say as x goes to positive infinity, right, that's this plus sign in the beginning, then f of x is going to go to negative infinity. This format can be translated all the way around the circle, so for the sake of your notes, you should try to write these 2 on the left. And if you will put a star in your notes, we can do a quick check of that tomorrow. All right, so let's talk about how you would graph a function. And this, again, would be how you would just sketch a graph without a calculator. Obviously, if you have one, hopefully you can figure out how to use a table of values to do that. So I'm going to just talk about this polynomial and some things that I notice. So first of all, I notice that this polynomial has a negative leading coefficient. I also notice that it has an even degree, and that is because my exponent is 4. And then lastly, I notice that this has a y-intercept of 2. So some things that I know about this graph at this moment are that it has, it's negative, so on the right side it's going to go down. It's even, which means the left side should match that. And then I also know that it's going to have a y-intercept of 2. Now in the middle, I don't know exactly what's happening, but I should be able to understand this to this point. The other thing that I can also know is that it could possibly have, because it has a degree of 4, it could have up to 4 zeros. Now I don't know that for sure, but I do know that it's possible that it could cross in like 4 different places. The middle part, we'll talk a little bit more about how we graph that later on, but for now, these are the things that you need to know. Okay, one more thing I want to go over with you is this table. And what I want you to see is some patterns that are happening that help us interpret what might be going on in the graph. So a few things. One, I noticed just right off the bat, I noticed some symmetry here between the 6, 6, the 4.5, 4.5. I also notice that somewhere between this 3, let me get my pointer, somewhere between these 2 values, I'm going to cross the x-axis because I'm going from negative to positive. So somewhere between 3 and 2, in this area, I should expect to see a 0. Similarly, between 2 and 3, I will see another 0. Notice that the graph is increasing in this first section because I'm going from negative to positive. And then at some point from in between there, I'm now, in this section, I'm now, actually for a few of these sections, this here is decreasing. So somewhere in this range, there's going to be a turning point. Notice you can follow that same trend on the other side. Again, the graph begins to increase from here, from this 2 to 6 section, the graph is increasing. And then again, somewhere from 6, it turns back around and starts decreasing. So again, there will be another turning point. So if we draw just a really, really rough sketch of this, kind of going back to the problem that we had, obviously you can plot these actual points. But I just want you to see that what's happening is we have a 0 occurring. The graph is increasing. It's going to turn around. I don't know what it's going to do there. I know it's going to go back up and turn back around. Okay, so I know at least there are going to be 2 zeros, and there's going to be these turning points, which you can see here. The turning points will end up being the maximums or the minimums. So make sure you write down that last note that turning points are relative maximums and minimums. All right, the last thing we're going to talk about is how to sketch a graph from a verbal description. So if you will pause the video and make sure you write down these different factors. The first thing I notice is that they've given me intervals of positive and negative. Remember, positive is going to be above the graph, or the y-axis, sorry, the x-axis, and negative is going to be below. And I notice that there's these points, 4 and -1 and 4, where some things are not either positive or negative, which means those are my zeros. So I have zeros at -4, -1, and 4. So I'm going to plot those on my x-axis, -4, -1, and +4. I notice that this says the function is above on the interval from -infinity to -4. So from -infinity to -4, we're going to be above the x-axis. That's going to look something like this. I also know that it's going to be positive from 1 to 4. So somewhere in this, sorry, -1 to 4. So somewhere in this zone, from -1 to 4, I'm going to be up here like above the axis. Now, let me just go ahead and sketch that, and then we'll adjust what we need to. All right, so I'm going to say that this looks something like that. Then it's negative below, so below between -4 and 1, so that's going to be down here. And it's also negative from 4 to positive infinity, so that would be 4 to positive infinity. So now we can note that there are some sections they say are decreasing and some sections they say are increasing. So decreasing is going to happen, it says, from -infinity to -2.6. So notice if I draw my little like cart here, this is my roller coaster person. Yay. All right, they're going down. So what that means, this whole section right here is decreasing, and it's going to decrease until we get to -2.67. So I don't really have this quite in the right place, but this low point should be at -2.67. So, well, that's not actually terrible. -2.67. Then it says I'm going to be increasing from 2.67 to 2. So from here all the way until I get to 2 right here, I should be going up. This should be increasing. And then again, it says from 2 to infinity, I'm going to go back down, so I'm decreasing again. All right, so that's how we do a rough sketch using a verbal description.